Okay, so next session. I'm going to talk about threat hunting with Kusto and give you some examples. We're going to go through some basics. Unfortunately, I don't have my colleague and partner on this one, Stefan Schörling. So I'm going to run this myself, and we're probably fine with that anyway. And also, super thanks to our sponsors, and it's the sponsor that makes these events to actually to work and make people able to organize these kinds of events, which is like super awesome, and super thanks to the organizers as well. A little bit about myself and Stefan as well. I work at OneWin based in Sweden, in Gothenburg. Myself is based in Stockholm. I'm doing a lot of both offensive security and defensive security, working a lot with threat hunting and working on a daily basis with Kusto. I've been doing that for a very long time. Some links to if you want to connect on LinkedIn, X, or just ping me in any community where you find me. All right, so the agenda, we're going to go through the basics of Kusto and look into threat hunting a bit, also look at the scaling possibilities, so you can run this across one customer or your own organization or multiple customers, and also a little bit on the training resource, so how you can become better at Kusto, except for attending this event, of course. All right, so Kusto is used to discover patterns and identify anomalies and outliers. We can do statistical modeling. We can structure the data, and we can twist and turn the data, which is especially important when you do threat hunting. Maybe you find something interesting and you wanna turn it around or correlate data with other tables that you have available. And of course, you can visualize the data using charts or using graphs to connect the dots. So where is Kusto? Kusto is is implemented in multiple places in the Microsoft world. But in general, you can say that everywhere where you can query data in some way. So I have the Microsoft Fabric. I think that Henning was mentioning that a lot in his session. We have the Log Analytics, which is the data aggregation platform for Microsoft Sentinel, and we can reach it from Microsoft Sentinel, which is the SIEM platform. We have the ADX, or Azure Data Explorer. We have Microsoft Defender XDR. We also have Azure Workbooks, and we have other implementations as well. Something that we used to say is that Kusto is the new PowerShell. It's something that a lot of people must learn, and your life gets a lot easier when you learn it. So how does it work? So the basics of Kusto, if we do it on a theoretical level, is that we have a data table, we apply a filter to that, and then we modify the data output, and we aggregate or join with other columns, and to get the data set that we want, and then we apply the final touch. Which columns do we want to show, or do we want to visualize the data, or show the top 50 rows or something? But this is like the basics that you're going through this on all your queries, and then you add more or less of these items. Some basic operators, the take or limit is to get a subset of the results. I use the take operator to, when I look into a new table that I don't know, or if it's the first time I look into it, or if we do a lot of incident response, and sometimes we get logs that we never seen. So basically, ingest the logs, and then we look at the first rows to see, which are the interesting columns, and how can you use this, what's the data types of the columns, and so on. So get a subset, and you sort of see how much it changes over the different rows. So for instance, take the first 10 rows, 20 or 100 rows, just to have a look at how it looks. There are also other ways you can do sample, just to get the sample of the table. We use the where to do our filtering. So for instance, where a column contains a value, or the aggregated amount or aggregated value is at a certain level. Or filtering on timestamps, or whatever is there that we need to filter on. For optimization purpose, we want to filter as much data as possible, as early as possible, and remove unused columns, because that will speed up the query, and we can add much more required data instead. The distinct is used to get unique combinations. One unique column, or the unique values of the column, or the unique combination of values. For instance, if you have one of the columns, or all the tables in Defender XDR contains the action type, which basically says what happened. And sometimes you want to see which action types do we have available for continuing our digging in the data. Then we can use distinct to return all the unique values. Order by to be able to sort on a specific column, if it should be descending or ascending. We use the summarize to aggregate data, count certain occurrence of a specific value, for example. Use join to build context between different tables. Maybe we want to have one column value from one table and another from another table. So we can join on some key values and then bring these tables together. Right, so we jump into demos. You can switch this. So this is in Defender XDR and the advanced hunting option that we have available. There are tons of data, but just to show you an example, we have the device process events. So we can start by doing the limits. Let's do take 10. Just to understand the device process events table. We can continue this. Let's remove the take 10 to not break anything. So we want to look for all the PowerShell executions. All right, so as you can see here, we have a lot of PowerShell executions. We have 2,760 items in the response. We can also use this quick search filter if we want to do that. But let's continue this, and we do another where clause, and we want to filter away everything that was initiated by system. Now we only have 7 items left. We can see on the date, and we can see the device name, and we can dig in and depending on how it was launched, if we had the initiating process command line and so on. The next thing we want to do is return unique value combinations. So we're going to do the unique of time generated. The thing with time generated is that almost all events has a unique timestamp. So unique time generated will actually will make all the rows unique. so it's not that useful to do a distinct. What we can do is group the time generated into an hour or a day or whatever grouping we would like to have, but that could help in this scenario. But let's remove the timestamp just for the sake of testing. And the other thing that we return is the action type. So we can see the action type is process created. We can also see the account name, and we can also see from which remote host this happened from. So this was an RDP session, and we can see from which remote RDP host this connection was coming from. We can continue this by doing a join, for example. Another thing here in Kusto that's really important is that we can have multiple queries in the same window by just adding an empty row between your queries. Usually when I do join, I test the joining query as well. So we have our left table, and we also have the right table that we want to join with. Just to make sure that we have the expected data in the right table, I usually do the separation, test running, make sure that it fits in what I expect in the results. And since this is a demo, I just translated my home IP into something else. So let's see. Unfortunately, we don't have any device name on the in the result from here. So if I join this, we won't have any results, unfortunately. But just a demo and show the execution. So what we can do here, and what the purpose of this is that we want to see the PowerShell process that is not initiating by system, and we want to look at the remote session device name to see if this was a remote session, and then we want to look at the device logon events to join these two into one result set. And the device logon events, what we're looking for here is the remote IP, and we also want to see the remote device name. And then we return the device name of the computer that sent the log, and the logon type, action type, and also this new column for the filtered IP and the remote device name. So what we want to do here is to join on the remote session device name with the initial query. So the thing that will happen then, if we had results from that, and that depends on the log source itself and the logon events and the actual values that we have there. But the idea is to get everything into the same results. All right, so let's continue in the presentation. There are also a lot of functions available that we can use. For instance, the count, so we can count the number of events of a specific, for instance, we want to count the number of network connections to a public IP by device name, and we can also group that, as I mentioned, on the timestamp or time generated into per hour. So for instance, show all the count the number of public network connections per device per hour, and then we can draw a visualization or a time chart of that, which makes it possible to see if there is a spike in the data, to see if there's one machine that stands out, for example, that could be worth digging into. We can also use the argmin or argmax to get the first event or the latest event. based on some criteria. For instance, get the first event of the first network communication per device for a specific remote IP, for example, to see when things started to go bad or something. We can also use sum to do math. For instance, if we want to calculate total amount of bytes sent, if we have a firewall log or any other log that has the data that you want to add to the math. We can also do if statements, and no, it's not a typo, it's double F in if in Kusto. And we also have functions to do IP geo-info. So for instance, if we find an IP address in a command line, we can extract the IP address and match it, use it regex or something else. And then we do geo-info from IP address function on that IP. So we can actually get the geo-info of the IP regardless of where we find that IP address. If there is in a remote IP column, or if it's in somewhere in a process command line or whatever wherever it is. The examples on the side here is some sort of pseudocode, but it gives you some idea how to use it. All right, so let's jump into the next demo. It will be a bit back and forth. So let's go into ADX. ADX is really useful, especially if you have data sets that you quick want to ingest, especially if you're working on a forensic task, for example. So you have all your log files, it could be CSV or other formats, it could be weblog, and depending on if it's in your own organization or if you're a consultant working for a customer, if you don't have these logs ingested into a SIEM platform so you can query it, then this is a really good way to work and scale the investigation. So maybe you have event logs for 100 servers, for example, and you don't have them ingested somewhere. Then you can import the event logs here, and you can query them and work with them, which is really efficient. So we look at this network traffic log. Move this on the side. So we have the time generated, we have source, destination, destination port, which service, sent byte, received bytes, and so on. So if we want to aggregate the data and count the number of events per source IP, we can do the summarize, and then I name the results to event counts. And as you can see here in the example, we have a new column called event count, and we can also see the source IP and the number of events. And we can change the orders and find the ones with most events. We can use the argmin to get the first event by destination IP. So with this query, we will only get the destination IP once, and we will get the first occurrence of that specific event. We can also do add the source IP to this as well, if we want to. It's good if you type it correctly. If you not only want to have the first per destination, you also want to have this first by source IP. Then we can add that as well. And if we look at the bytes, I'm not sure for everyone else, but for me it's easy to recalculate to at least kilobytes. Otherwise, it looks as much more data than it actually is. So we do the summarize, and we name that column kilobytes per day or kbytes per day, and we do the sum, sent bytes, divided by 1024, and we group it by the source IP and also per hour, per day. Now we can render a time chart if we want to. I mean, the table is great, but for me, if I look through thousands of rows of data, it's difficult, for me at least, to see what stands out when I look at the table. I'm more like a visual person, so for me it's much easier to look at this, at the time chart to understand if something stands out or if there's something we need to dive into and investigate further. And we can see the source IP and so on, so we can see if this looks pretty equal on all the source IPs actually. We can also do the if statement. And in this example, I want to see if the aggregated kilobytes per day is more than 1,000. Of course, the values depends on the situation, but if it's more than 1,000, we add a value of potential exfiltration. If it's not over 1,000, we just add normal. Now we add the new column that we call bad limit, and we can see where things starts to change. Instead of if, we can also do case. So if we have multiple evaluations we want to do, if it's more than 500, then add this. If it's more than 1,000, do this. If it's more than 5,000, do this, and so on. And we can also get the geo-IP info. So in this query, we do our table network traffic. We create a new column with extend and call that IPGeo. And that data, that column is populated with data from this function, geoinfo from IP address. And this function has a parameter, so we add our destination IP in here. And this will give us a dynamic value, or JSON blob sort of, that contains, so it's an object with multiple properties. So what we do is that we create new columns with, I want a separate column for country, and I also want to have a separate one for the city. So in the country, we add the ipgeo.country, and in city we add the ipgeo.city. If we want to see how that looks like on the first response, we can actually do like this and just keep the IPGeo. So this is the object that we get in the return from the function. So we can see the country, we can see the state, if there is a state available. We can see the city, latitude, longitude. And if we want to do this much further, we can draw this on a map, for example, so we can draw connections between it, or see where in the world we have more logons, for example. Okay, so let's jump into the slides again. Another function that I think is very useful is the external data. Maybe you have a list of data. It could be related to specific users, a user list, or if you have a list of bad IPs. And if you can update this CSV file or whatever format it is on an automatic way, then we can use Kusto to read that data. As long as it is in a public place, it could be on an Azure storage blob, or if it's on GitHub or whatever it is. Then we can use the external data to get IOCs, for example, or other data that you want to use in your query to correlate with the data that you have ingested in your platform. One common thing that we see out there is that external data is used to read one of the public IOC file lists that could be available on GitHub or any other website. Right, so let's get into a bit more of hunting. And depending on the sources that you have, I mean, this session is more focused on Kusto than on specific tools, depending on the source, and in this case, we're using Microsoft Defender for Endpoint or Defender XDR. So we look for device logon events where action type is logon success. Sometimes attempt to logons are interesting as well. And we want to look for where the remote type is public. If you have data that doesn't have the information if the remote type is public, I mean, you can calculate based on depending on the IP address itself, if it's starts with 10 or if it's 192.168, for example. But you can also use a built-in function to calculate if it's in a private range. And then if it's not in private, it's probably public. So we look at the logon success. So just to show it graphically, devices residing on the internet, and if they log on to a device using RDP on 3389 or SSH on port 22, for example. And it doesn't matter if the device that sends the data is located on-prem or if it's at home, in a home office or somewhere else in the world. We can still get this data because all the devices are sending the data or the telemetry to Defender, and we hunt from the cloud service on data that is already there, so we don't need to touch the endpoints. Another scenario, I mean, it could be that you can use this as a custom detection, or if you want to use it as manual hunting. The hunting itself could be if it's proactive hunting or if it's reactive hunting. But in this example, I create a variable of the ports I want to look for. So in this case, it's WinRM and also RDP. I also define the privileged access workstation network and also continue the query with device network events. And then I want to look for the, where the action type is inbound connection accepted. So I look at the remote devices when they have inbound traffic. And where the IPv4 is in any range, so I look for the remote IP, so I look at the remote IP itself and see if that matches the PON network. And then we can decide, should this be allowed or if it doesn't, is allowed. So from this way we can, I mean, you can't take this query and execute it in your environment as it is. You need to define the networks, maybe you have other networks. But the idea here is to look for traffic inside your network that is suspicious. I mean, RDP is not a malicious protocol by itself. It's just something that shouldn't be used everywhere. So for instance, if you have RDP traffic from a regular user device from the client network coming to the servers, and if it doesn't come from the admin network where the local IT is connected from, then you can alert on this, or you can flag it as suspicious. Or as shown on this picture, if you have connections to a factory network that is not expected. So maybe you expect it to come from this admin network, then it's a green light and you're good to go. But if it comes from the client network, then you should alert on it. So this is how you can monitor your internal network and see if you have any connectivity to management ports from places where it shouldn't come from. Another thing with threat hunting, and where Kusto stands out a little bit, is depending on the platform and the language you use to, some SIEM languages is more or less searching for strings like you do in Notepad, or where this column has this value, for example. But what you really want to do is aggregating the data to see if it is different than expected. So maybe you want to look for a specific event, but the event before must contain a certain activity, or the event after should be something. We can also calculate anomalies and make a time series of the event and see the probability of that event to actually happen. And if we look at this anomaly series, we can see in this example there's a difference where we should be and the event that actually happened. So this is how we can see if something is an actually anomaly. One thing when calculating anomalies is that you need to have a certain number of days just to be able to do a proper calculation. For example, if you look for anomalies in your logs based on how many times a certain web app is used, for example, and if you have and if you compare on a Saturday to a Friday, it's probably going to be a difference in the logs. But if you look over time, it can actually calculate that it should go down on the weekend or should go up on the weekend. So this is really useful in terms of finding real anomalies. Right, so demo, show. In this example, we continue to work with the network traffic, and we look at the destination port equals 443, and we want to group per hour, and we want to make a series on the distinct count of source IPs between the selected timestamp. And one thing I realized from working with this type of statistics is that it could be sometimes inside your organization you have the BI team. They're probably really good in calculating different statistics and so on. I really recommend to talk to people that already work with these kind of things and ask them for help. For myself, I still have so much to learn when it comes to statistics. I'm even looking into maybe taking a math class just to become even better at it. And even if you don't do that, another way to learn is just to keep on doing Kusto and keep on doing this statistic calculation just to move forward and try to really understand how it's calculated and compare the anomaly that you know about with the results from the query itself. So when we run this on this firewall traffic log, we can see that compared to the baseline, we have something happening over here, and we can see like increase of number of events based on the destination IPs. So this is how we can work with it. And as I mentioned earlier, it's really important to do the visualization to make it much easier to see if there is something that stands out. Graph semantics. I can't really say it's the new cool kid on the block, but it's somewhat new to if you compare to other things. I think it was in preview around this time last year, and it was GA during the summer or something. But this is how we draw the relationships between objects, and I think the easiest way to explain it is if you look at a social network and you want to look for all the friends and the friend of a friends to the end of that social media, like all users at the social media. So we want to see if we start from my user over here, and then I'm the friend with someone over here who is friend of another person, so draw the whole relationship of the whole social media, basically. And this could be used in threat hunting as well. So maybe if we find a threat actor that's using some custom ports on the internal network, we can draw the relation between all these lateral movements to easier understand where were they, how did they get there, when did they get there, because graph semantics is time aware as well. If we compare to SQL and joins, yeah, we can achieve some parts of this with SQL join. The difference is that when we do this with SQL join is that we need to know the number of relations. So we need to do a join for each relation, and with graph semantics we get recursive joins. We don't need to know this because doing joins wouldn't work on a social media because it could be any number of connections. And I'm going to demo this, but I also know that after the break there is a session with Fabian Bader who's going to deep dive into graph semantics. So I try to keep my my time slot here and leave the demo for Fabian. We're going to show a few demos. I expect you to stay on this event anyway. All right, so it's going to make sure that we're in the correct cluster. So this is ADX, and so what I want to do here is jump down to demo query. Yeah, you can start with this one. One thing with ADX, if you run a full cluster, is that you can use a Python plugin, so we can actually visualize this. Everywhere, or at least everywhere where I've seen, there is support of graph semantics, but with the table views. But this is one of the ways you can use to plot the relation between the nodes. So graph semantics is divided between nodes, which is an object with different properties, and edges, meaning how they connect to each other. So I'm using a Plotly plugin, a Python plugin for this, and we executed a query, and I've defined the tables in this one because I didn't have the correct data sets in this cluster. So we create a visualization, and we create the Plotly one. So in this one, we can see that PowerShell was executed, and we can see like the connection between different child processes and how they were executed. Oops. If we can zoom out a little bit. So this is not a super advanced graph, but if you look at this point here, we have PowerShell, and over here we can see that it then executed who am I. It also executed ipconfig, and it also executed nslookup, for example. So this is how we can keep track and draw the graph and see, and we can also do the filtering and like the where clauses and so on to make this, to draw the actual attack chain and which tools was executed in which order, and then we can find all these occurrences across the domain. We can also show another demo. So add the Plotly visualization to this. If that works. All right, so we have this, I'm not sure if it's visible enough. We have this client 2 connecting to, and we call the connection edges to attacks. So it connected to client 1 on port 445. And from client 1, there are multiple ways. So we can see that client 03 was also in the chain. So client 2 to client 1 to client 3 to the server 01. There's also another connection to, let's see, over here, and then it continues to the DC01, and they also had another route to Finance 01. And from Finance 01, they connected to the domain controller as well. So we can draw the map and visualize how the threat actor was moving in the environment. Of course, this requires us to understand how did they move so we can do the correct filtering and so on before. We can't just go to any environment or any customer, execute this and draw the attack map. Of course, we need to understand how it happened, but when we do know how it happened, we can draw all occurrences of that event or that attack.
It's graph semantics.
Oh. Yes.
It's graph semantics.
This is worth running again. Sorry for that.
How hard can it be? It's graph.
So the scaling possibilities. In the Defender XDR world, we have the multi-tenant portal, the mto.security.microsoft.com. So if you have access with your account to multiple tenants, you can use the advanced hunting across all the tenants, which is really efficient because with Defender you have access to tons of data, and you can also scale it. So if you see something in one tenant, you can also see if that happens in other tenants, and then you can see if maybe this is a false positive because it's like common behavior, or you can see, for instance, if you have email campaign targeting many of your customers, you can see which customers are affected instantly and also take actions, and you can see like the incidents and stuff. But this is one way to scaling. Another thing is if you have multiple workspaces in Sentinel, you can do querying. One thing that is important to understand when you're querying a workspace, and if they have logging enabled on that workspace, it could be that you, and if you add your multiple workspace to your queries, all these will end up in the target workspace as well. And of course, use ADX. ADX is one of my favorites, especially when we do incident response, because it's so easy to upload the data and scale the hunt across multiple log sources. There's also APIs that you can look into. We have the Advanced Hunting API, we have Jupyter Notebooks, and there's so many things that you can use for it. And also in terms of scaling, we have the Fabric as well. Training resources. Kusto Detective, super fun way, gamified experience to learn Kusto. And also the Kusto documentation, I think it's really useful because they have examples, both examples on the data and the actual expected results from it, and you can see if it matched what you're looking for. We also placed a link to other Kusto learning resources, and also from the community, the KQL Cafe, run by Gianni and Alex. And thank you.